So picking up from what we discussed earlier, in the previous videos you have looked at surface integral, right? And then you look at the two different methods, and then after that you look at the surface integral in scalar fields. And then in this video we're going to look at it specifically for vector field. Alright, and then for vector field, later you will see that, as you remember earlier, I said that I'm going to inject a unit vector normal because that is something that you are going to use as part of the formula that you see in surface integral in vector field. So let's start with finding unit vector normal. Alright, so as you can see, if I have unit vector normal n, so usually just to differentiate it, you can see that it's actually an n cap. Alright, the formula for it will be basically my n, vector of n, divided by the magnitude or the modulus of my vector of n. Alright, and of course this can also be expressed in terms of my gradient that you see here, the nabla. That is what they call as gradient as well. Gradient of f being your vector, alright, over gradient of your vector f, the modulus of it, alright, where your gradient of f basically means what? It actually means the partial derivative of my df over dx of I plus df over dy of your j plus df over dz of my k. Alright, so say if we are to find unit vector normal of n, in which it actually lies in my xy plane, I can also write this as n cap equal to negative df over dxi minus df over dyj plus k divided by square root of 1 plus df over dx square plus df over dy square. Alright, so this is one of it. Alright, and what if, just for example, if instead, I'm just going to use it in different color maybe. Let's say if it's in yz plane instead, how are you going to find it? So again, just the same. Notice that for xy plane, and of course, you just want to make sure that this is a negative, this is a negative, and this is a positive, yeah? And for xy plane, you can see that you actually have a partial derivative of dx and dy, and then over here would then be a dx and dy. Alright, so just in case you're wondering, alright, now I want to get my surface, my unit vector normal. Alright, and my unit vector normal is on my yz plane. So again, it's the same thing actually. So I'm just gonna scroll it up here a little bit. I'm gonna write it in purple. If it is on a yz plane, then see how it actually changes here. So instead now I will have a negative df over, you guessed it right, so that would be dy of my j, alright, minus df over dz of my k, now I plus I, over square root of 1 plus df over dy square plus df over dz square. Alright, so again, just the same thing, even if it's an xz plane. So you guessed it correctly. So just use whichever term that you have for this plane that is involved to be the first two terms, and make sure that it's actually of negative, and then the remaining term will then be a plus. And of course, as you have guessed it correctly, as you can see already, the denominator actually has the same formula, only that again you can see that all the denominator will be in correspondence will correspond to my y and my z. All right, like for example, this one is this x and y, then this is x and y here. So of course, I just want to reiterate one point here. So basically, if you notice, unit vector normal actually is given by two different methods as well. All right, do you realize that earlier we actually have this? This is actually method 1. All right, so first, I think you're quite familiar with this already. Probably this is something really new, but format goes the same way. All right, only that you will find your nabla of f, in which nabla is just obtained, or we call this the gradient. Yeah. All right, gradient of f, gradient of vector f. And how you got it? You just basically do a partial derivative of df over dx, I plus df over dy, j plus df over dz, k. So this is actually method 1. All right, and the ones that you see over here, all right, this is actually of method 2. Of course, like I mentioned again, this is not fixed. The one that I'm circling here actually corresponds to xy plane. So you just change your plane accordingly depending on what you want to do. So again, there's no any right way for you to do it, but as you do more questions, you'll find out that maybe certain method actually suits you more than the other. All right, if you are okay with this and you have understood this, let's try out example 2. All right, and it's actually in the next video. So we're going to explore these two methods in solving example 2, which is actually in your tutorial question, second tutorial question of question 1a. So let's have a look at that. Okay.